Hey guys, in this video we are going to talk about one of the common problem that we are going to face when we are training any deep learning model, that is vanishing and exploding radiants. So this is one of the common problem that we are going to face when we are training any deep learning model, guys. Now why does that occur? Now think about this, guys. So how does a neural network is being trained? Let's consider this example neural network that I have already drawn over here. So I'm having my input layer and this is connected to two hidden layers. And from the second hidden layer, I have connected to a single output neuron. Now the way this training would happen is, first I'm going to perform a forward pass. Okay, so from this forward pass, I'm going to compute y hat, and from this y hat, I'm going to compute loss. On that basis of loss, I'll see, okay, so this is the loss. So the next step would be finding the gradients with reference to this loss function with every parameters that I'm having over here in this neural network, and then update my parameters using those gradients. Now, can you imagine the complexity that is involved over here? So I have to perform the forward pass, and this is followed up by finding the gradients. Okay, so I'm having a deep learning framework already with me, that is TensorFlow. So it will make use of tensors and all the other functions which is present over there and computes these gradients for me. But the issue that we would actually find is, while training this neural network, as the training progresses, what would happen is, see, when I'm updating this layer, okay, let's say my gradient value is very small. Okay, my initial gradient value is very small in this layer. When it reaches deeper and deeper, that means when it is going in a backward manner, at that scenario, it would become even smaller as well. That means in the starting layers, there won't be any considerable changes in the parameters, which means gradient just vanishes and it will not be able to update the parameters of my deep learning model. And the opposite can happen as well. So as I find the values of gradients, so it can just grow larger and larger, and it actually can make my deep learning model deviate from the correct values itself. So this is one of the common issue that we'll be finding when we are training any deep learning model. And this was that issue when people were training the deep learning models in the early years of 2000s. So in the early years of 2000, so when people came across this problem, they actually left the hope and they said as, okay, so I don't think this deep learning is going to work. And in the year of 2010, there's a person called Xavier Glorard, and he actually found the reasons, and he actually suggested some of the improvements that we can do while training, which would actually help us reducing these problems of vanishing and exploding gradients. So we know what the problem is. Now let's look at the solution that we have with us. Now, what people used to do was, okay, so when we are training any deep learning model, they first thought a solution would be, since they were actually using sigmoid as a activation function over there. So what they suggested as, okay, so when we are initializing the parameters, instead of performing the random initialization, let's follow some rule. The rule is initialize the weights such a way that it has 0 mean and standard deviation as 1. So that was one technique that they have decided that, okay, so let's use this. That means having the normally distribution. So when we are initializing the weights, we'll make sure that it will have the normal distribution values. Okay, now on that basis of strategy, they have actually proposed various initialization techniques which are actually suitable for various activation functions, guys. So some of the initialization techniques are the common ones are like Glorard initialization techniques, and we use this initialization technique when we have the activation functions of tanh, logistic model, that is the sigmoid activation function, also the softmax activation, and we'll make use of he as the initializer when we are working with ReLU and its respective variants. And there was one more initialization technique that is called as Leaken, and this initialization technique is proposed for the activation function of CellU. So we'll make use of these various initialization techniques while applying on their respective activation function to make sure that I'll not be getting the vanishing and exploding gradients problem. Okay, so this is one solution, and the another solution is like at that time they have actually discovered as like instead of using only tanh and sigmoid. So previously when people started building the models, so they were actually using two activation function. One was sigmoid and the another one was tanh, and they found that instead of using those saturating activation functions like sigmoid and tanh, they discovered the ReLU and leaky ReLU and its respective variants, and using those activation functions they have found that the vanishing and the exploding gradients problem can be reduced. And the other technique that we have over here is batch normalization. Now using this technique, we can also perform any additional normalization that we want to do on our neural network. So even though we might have taken care during the weight initialization, so we could further reduce the chances of coming back, that is the problem of vanishing and exploding gradients, by performing batch normalization. And the last but not the least, another option that we have is performing the gradient clipping. Now here in this scenario of performing the gradient clipping, we can mention the range. Okay, so this is the maximum range for my gradients and this is the minimum range, and by specifying the gradient range we can actually clip it, even though if I am getting a larger gradients when I compute it. With the use of clipping we can just limit those values, guys. Now as you can see, so we have various techniques which will actually help us to reduce the chances of getting into this vanishing and exploding gradients problem. And as you can clearly see, so each topic requires a further explanation in depth as well. So what we'll be doing as part of our learning activity in this YouTube channel is we'll go in depth about various techniques that we have to solve this vanishing and exploding gradients, and we'll be linking it into the description as we progress. Please don't forget to check out our YouTube channel as well to get the latest update. Alright guys, so please remember, this is one of the common interview question. You may not require to explain all these techniques, but you need to remember this. What are the techniques that are actually out there which will help us in solving this problem? So one is the weight initialization techniques. So some of the weight initialization techniques are GloRod, He and Leaken. So GloRod is for sigmoid activation function, He is used for ReLU, and Leaken is for CeLU activation function. And along with that we can actually try to use the non-saturated activation function, which would further reduce the chances of the problems of vanishing and exploding gradients. And we also have the techniques of batch normalization and gradient clipping. So I hope this video has been helpful to you. So this was a short video on this important topic, guys. If you're new to our channel, please consider subscribing, and there is already a deep learning playlist. So do check out the link in description, and I hope you like it. Thank you so much, guys. Happy learning.